Hello, I'm Dr. David Kordowitz and welcome to Programming. Today we're going to be talking about the three different types of files which you can create in MATLAB. These three types of files are scripts, live scripts, and functions, and we're going to describe the differences and similarities between them as we move forward. Let's begin. The first step is creating a new file. To do this, we have the ability to create a new script or a new live script. We also have this pull-down menu for new that gives us a bunch of different file types that we can create. However, for everything but live script, we can just use the new script command, and then depending on how we structure our file, we can get every one of the other file types. So let's go ahead and hit the new script, and when you do this, an editor will appear at the top of your screen. Now, this editor, if you're in the default mode, will be what we call docked. It will be above the command window, but still on your screen. If you wish to undock it, you can click the little arrow at the top of the box, and you can click the undock command. You can undock the entire editor or just the tab that you have open. So if I undock this, now it'll appear in its own separate window. However, docking it usually makes things easier for you, and to redock, you just click the down arrow again and hit Dock Editor. Now that the editor is docked, I want you to look at some of the characteristics of the editor. The editor looks like just basically a blank screen similar to the command window. The difference here is that within this editor, we can save whatever we type in here and run it over and over and over again, or if we choose to make a function file, we can use that the same way we used functions in C and C++. Now, on the right-hand side of this box, you'll see there's a little green box. This green box is what's telling us that the code is okay. This is something called lint, which was developed originally for C and C++ and Java and Python and other languages. But what it does is it checks the syntax of your code to make sure that there's not likely a mistake in that line or that there's not a major error. This will change to orange if it thinks that there's possibly an error, and red if there definitely is. I typically start my script files with something to the effect of clear vars close all and CLC. What this is going to do is clear vars is a new version of clear all. Some people may remember close all, clear all, CLC. Clear vars is going to clear all the variables that existed already in our workspace before we start running the script. Close all will close all open windows. This becomes relevant when we start dealing with plots and images and things like that. CLC will clear the command window so that if we end up with errors on the screen, those errors are guaranteed to be from the particular run you're looking at. Now, we can do something very simple here, like A equals 5, B equals 6, and then C equals A times B. So this would be a valid script type file. Now, what's going to happen is we're going to set A equal to 5, B equal to 6, and then A times B is going to be C, which means we should get a value of 30. To test this, we can do one of two things. We can use the Control-Enter command to simply run through the code and source the file, and we can see that C in our workspace is equal to 30. This, however, is not the best way of doing things. We could also save our project here, Control-S to save, and in fact, that is not the directory I want to be in. I would rather be in my directory for my MATLAB drive, so I'm going to save that, and let's do intro.m. So .m files are MATLAB runnable files, text files. So now if we run this again, we can hit the run button up here at the top, and by doing that, it will execute the code and give us the value, the response. If we want to display that value, we can use the disp command and do disp C simply like that, and we hit the run again, and you'll see that it shows 30. One important note here is that the disp command allows you to do different structures and lay different things out. Also, when you hit the run button, one important note here, when you hit the run button, it automatically saves whatever code you're working on. This is important because if you forget to save the code, if you've run it recently, it will be saved. If you press Control Enter, however, it will not save your work. So that's an important distinction there if you're working on big programs. So now, this is the most basic type of file. This is a script. It just starts at the top and works its way through. Now, there's many times that you want to see really what's going on. Now, this isn't all that important when we're talking about this type of layout for something this simple, but as we get more complicated, it may be useful to use what we call live scripts. To create a live script, we're simply going to go back to our home group and hit the new live script button. Live scripts have the extension .mlx for MATLAB live script. And so let's put the same code we had over here into our live script. So we're going to copy it and then simply come over and paste it into the other tab, just like that. Now we can save our live script and we're going to call it intro.mlx. And now we can run it. So to run a live script, we can use the live editor and hit run, or you can hit Control Enter or F5. So if we hit that, it runs and we can see that the result is put on the right as 30. Live scripts are really handy because especially when you have a lot of windows that launch, it will put them on the right. The other thing with live scripts that you can do is you can add section breaks and add text to your live script much in the same way you would, say, in a Word document. So, for example, I can hit text and say, this is an intro to MATLAB. And then you can continue down and then we can do more code. I can hit the code button and start entering a second block of code. This is incredibly useful if you want to use this to make final display and nice pretty diagrams. Okay, so now that we have that, the last type of file which we need to worry about is a function file. Functions work in MATLAB much the same way that they work in C and C++. However, they must be in their own file. So let's create a function file here, and we didn't want a MATLAB live script, so we're going to go new, and we're going to get a function. Anytime you're doing a function file, the first word in the file must be function. So we're just going to simply type function, and you'll notice that it turns blue. We can then put our return value in square brackets, so say, for example, a is equal to, and then we're going to give our function title, and then let's say add two numbers, or nums, and then we're going to put in parentheses our parameters, so C and D. Then all we need to do is we need to assign our output. So A already exists as our return value, and I can say A equals C plus D, semicolon. A lot of people will add the end at the end of their function to end the function command. This is important when you're doing things like embedded functions, which go beyond the scope of this course. Now, it's important that when you name your function, that you save the function file as the same exact name as you named your function in the command. So we're going to save that. Now we need to run it. You can't run the function file simply by hitting the run command. If you do that, you're going to get an error which comes in red. All errors come in red, and it will also take you here and show you what went wrong. So we can say, for example, now add two nums, and I'm going to use my tab completion, and we can say 3, 5. So we know that if we add 3 and 5, we get 8. So if I push enter, we get 8. That is running this command. Now, an interesting thing about functions in MATLAB is they can have multiple return values, unlike C. If you want to add additional return values, you simply add more values here. So A, B. So now our function can return, say, B equals C times D. Now it can return two variables, two values. However, if I run it the way I did before, I'm only going to get the 8 because that's the C plus D, because that's the first parameter. If I want to give both, I need to use an array return. So I'm just going to go square bracket. I'm going to go say A, B equals add 2 2 nums, and let's say 3 and 5 again. And when I do this, I'm going to get A is equal to 8 and B is equal to 15, which is exactly what we'd expect. So functions are really interesting like this, that you can have more than one return value. Now, this becomes really important in MATLAB because there is no pass-by reference or pass-by value. That doesn't exist. You can also use the nargout and nargen commands if you want to allow your function to take differing numbers of variables. So for example, if I said C, D, E, now I can say if nargen, N-A-R-G-I-N, is equal to 2, then we're going to do A equals this, and then we can say else A equals C plus D plus E, and B equals C times D times E. And then we have to add an end to end our if. So if we do that, now we can save this. And now if I run this again with 3 and 5, I get the exact same response. However, if I said 3, 5, and 2, now I'm going to be adding an extra 2, so 8 plus 2 is 10, and 15 times 2 is 30. So you can see how you can use this to your advantage to be able to jump to different values or take different numbers of inputs. One other important thing that we have is the debugger. This is a little different than the debugging methods we taught previously. The debugger in MATLAB allows you to jump to a specific line. So let's say, for example, I have my intro here, and I want to see what happens here. I want to see the values of my variables here. Now, if I hit the run command up here, it's going to run my program, and it says, okay, because there's another intro, so it's telling me I can't do that. So let's go ahead and save this as intro 2. And now if I put this red dot back here and I click on the run command, now we're going to stop and we're going to have a green arrow here. This green arrow, and then I have this K command, which is telling me that it's broken. What that means is that we've stopped at that line. Now that we've stopped here, we can see that A is equal to 5 and B is equal to 6. We have a few options about what to do now. For example, I can use the step command to simply run this C equals A times B. So if I hit that step command, it jumps and we now have C equals 30. We have our step in command, which is if you have functions or other subroutines, the step in command will step you into those functions and allow you to debug those functions. The step out command gets you back out. Run to cursor allows you to put another breakpoint in, and continue will run until you hit another standard breakpoint. So let's try this. Let's continue, and now let's go ahead and add in our D, E is equal to our add 2 nums of 5 and 7, for example. And so if we do that, we now have to save this again, and let's run it. So we're going to compute C. So we can step to compute C. And now let's step in and see what's going on with this function. So we can hit step in, and now we're in here, and C is equal to 5, and D is equal to 7. So we can step in the function, and we see that the number of arguments in is that. We can do, say, for example, now we're good. We know that that's working. We can hit step out, and that brings us back here. However, it brings us before this is completed. So let's do step to complete that computation, and you see D and E. Thank you for your time today, and see you next time.